In the year 1202, Leonardo of Pisa, better known as Fibonacci, uncovered a link for merging the study of mathematics, nature, and art. Not only did Fibonacci introduce the Christian world to the Hindu-Arabic numerals we use today, but he also posed a seemingly innocuous problem about bunny rabbits. Fibonacci wanted to know how many rabbits would be produced in a year, beginning with a single pair. He assumed that starting in January and continuing every month thereafter, each pair of rabbits would bear a new pair once they were a month old. As he worked towards a solution, he noticed a pattern emerging. The number of rabbit couples increased in a certain sequence each month: 1, 2, 3, 5, 8, 13, 21, and so on. Each number in this series equals the sum of the two previous numbers. 3 plus 5 equals 8, 5 plus 8 equals 13, and so on. These numbers, growing to infinity, are known as the Fibonacci series. This may appear to be of little consequence, but these numbers would become the key to unlocking more mysteries than a plague of bunnies. For instance, in the field of botany, the structure of flowers is based on Fibonacci numbers. Lilies have a radial symmetry based on 3. Violets have 5 petals. Sunflowers have petals totaling 33, 55, or 89. This phenomenon, not explained until 1993, appears to go beyond genetics to the natural dynamics of growth. Whether it is the spiral of consecutive seeds in a sunflower, the spiraling growth of a chambered nautilus, or the branching structure of bronchi in the lungs, organic growth is often guided by a mathematical ratio stemming from the Fibonacci series. As Fibonacci numbers increase, the proportion of two successive numbers becomes more and more similar. The ratio approaches but never reaches an infinite decimal beginning with the numbers 1.618. This ratio was given the name the divine proportion and was later called the golden mean. Eventually, it was given the abbreviation phi after the initial of the Greek sculptor Phidias, creator of the artwork on the Parthenon. As early as the Pythagorean school in 500 BC, the Greeks studied the ratio of phi and developed a method of constructing a rectangle with sides measuring 1 and phi. With a perfect square, a line from the midpoint, and an arc, they created what was later called a golden rectangle. The Greeks also found that if they removed the original square, what was left was itself a golden rectangle. The Greeks believed that the golden rectangle held a mathematical key to beauty, and they incorporated it into many designs. The most striking example may be the Parthenon, with most of its proportions based on golden rectangles. The Greeks were not the first to use the visual balance of phi in their architecture. 5,000 years ago, the Egyptians based the design of the Great Pyramid of Cheops on golden proportions. This measurement may not have been intentional, but it reinforces the belief that phi holds some universal aesthetic appeal. For centuries, artists have studied the psychology of beauty, while biologists have sought to untangle the complexities of nature. Yet it was Fibonacci, an Italian mathematician 800 years ago, who found the common mathematical thread that connects these two disciplines and provides a deeper understanding.
Individuality, the trademark of any artist, designer, or architect. Each desires a uniqueness to their creation, a quality that separates it from any other. Man naturally has this individuality, his fingerprint. There are 6.5 billion people on the face of the earth, and no two fingerprints are the same. Everything we touch or make contact with is branded with a small expressed image revealing to all who see it who was there. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design that the tiny shell is formed. This sequence, or blueprint, appears to be the trademark of a designer, a proof of a creator, something left behind indicating the one who was there, a fingerprint. As we scan our universe, from the tiny flower to the awe-inspiring galaxy, we see the fingerprint of God. And we are forced to ask, who is God?